All right, we'll go ahead and get started. We got a lot of information to cover. It's the 2024 IECC significant changes for residential. This is not quite finished, I believe, on the final publication. It will be coming out in January of next year. We have heard that there are a few cities that are already going to look forward to adopting this. That's why I wanted to go ahead and start bringing this out. This is still an updated version and different drafts that come out that changes do happen. So it will be updated as we go through it. And as we see other cities start to join with this, we'll keep bringing this up from time to time to go through that. I know it's kind of a lower attendance today just because a lot of people are still on the 21 or they're on the 15 or the 18. But this is kind of gives everybody an idea of where these changes are going, where they're going with the IECC and the energy efficiency of what they're doing in codes these days, and kind of looking forward to the future about what you're going to see come through. Most cities around here that we actually talk to, they usually adopt an every other code cycle, so that's every 6 years. And so that's kind of why we're bringing this out. There are some on the 18 that's going to 24, some on the 15 that's going to 21. So we'll go through this. As always, today's webinar is being recorded. It will be uploaded on YouTube channel, where you can find by searching SPEAR on our YouTube, or you can go to our website directly and go to eepartnership.org, and under the news section, you'll find our resources page. Once you're on the resource page, you'll see a link to our YouTube channel. Within 72 hours of the presentation, you'll receive a course evaluation email from Kathy Lawrence. She's usually quicker than that, but I like to put that in there just in case we have some people out. Please complete the survey and send back to her to receive your course completion certificate. That will contain the course ID number you'll need when reporting your CEUs to ICC. Lastly, as always, I have the chat feature open. I'll be happy to, please use that to report any technical difficulties you might be experiencing during the presentation. The Q&A feature is also open. Please use that to post any questions you might have. I'll try to go through those as we go through the presentation today. So I broke it up into two sections due to the number of changes that were happening. I couldn't really include residential and commercial. So it's just residential today, and then part 2 weeks from now, and then we'll do the commercial in 2-part series as well later on in the year. But what we're going to go through today is the residential chapter changes. I only made it into the midway through chapter 4 at the end of the table that's there that we'll look at. We're going to see chapter 1 changes, chapter 2 changes, chapter 3, and chapter 4. Those that it's their first time here, we have a lot of new people that sign up for our newsletter and then join us for the first time. SPEAR is one of 6 RIOs throughout the country where it's considered a regional energy efficiency organization. We are nonprofit. We are member-based. We've got 50+ members across a wide selection of energy efficiency industries, manufacturers, other organizations, other nonprofits, looking to advance and enforce the newer energy codes as they come out. Our focus mainly is on outreach, education, and collaboration. This is all I do all the time, is do training. I do webinars, I do in-person, I do field trainings. I can also help on a one-on-one basis with an IECC test prep training. We're trying to get approval now through ICC to see if I can put on one that's more of an open source where we can have more people join. And we can try to give that to people that are looking for a test prep for training for the test, if you're going to try to get that. The price is always right. Of course, it's free. All of the stuff we do is free. So I can help with questions regarding any energy code that's 15, 18, 21, the 24, and anything older than that, all the way to 2000 with that part of it. We answer a lot of questions through plan reviewers and building officials and third-party energy inspectors, as well as sometimes I have some manufacturers that have reps on here that just kind of listen to what's coming up and what's going on. There's a lot of groups like us that will present an upcoming changes in the new energy code that's coming out, just to start getting their audience ready for that. And that's kind of why we're here to do that and here to help. We also have been proud to assist some cities with the adoption of the 2021. We can assist with navigating amendments, what other cities have done, what will lessen the impact for the adoption when it comes to your building industry that's there. You don't really want to have all of a sudden a bunch of I codes being added and it scares off builders. So a lot of councils look at that in high regards to say, look, we need to not really have an impact that's going to really shake the ground and cause building to slow. We all know that and mortgage rates have gone up and building is kind of slowed down a little bit. So just keeping that with a lesser impact helps with adding amendments that will actually ease some of that burden. My contact information will be at the end of the presentation. Please feel free to reach out to me with any questions that you have. Share my information. I always welcome pictures so I can use it in my webinars. And if I use it, I will give you credit for that and tell them where it's come from. So I just am not out in the field as much as I used to be. So I don't have a lot of opportunities to grab things when it's wrong. And trying to do a Google search and finding pictures to say this is correct and this is incorrect is much harder than you think. There's not a lot of pictures out there to find things that are wrong. And so any help that you can provide for me would be greatly appreciated. And then again, I will actually give you credit for that as I put it in the webinar. So the 2024 IECC. So we've talked about this in previous webinars, but the update process for the I codes have changed. It's now an ANSI standard approval method, which opens more of a public comment time. It's longer. They actually have subcommittees that look at each chapter. They look at each I code. They meet multiple times throughout almost a year's process. They go through multiple repeated meetings and revisions to proposals to try to help make the best proposal option reach the code if they actually deem that it's going to be an improvement for the code and an update to the code. So they do the best that they can to try to get that pushed forward, and then they bring it up to the actual committee. They make their approval recommendations, and then it tries to make it into the code. So it's a more open process. I think it's better for the I codes. It's much better for the energy code to get other people's point of view. You'll see in these slides coming up that there are things changing in reverse. And a lot of that is because there are now people specializing in insulation and specializing in building science that actually brings their expertise to forward in the committees to talk about, hey, just increasing insulation doesn't actually make this better for everyone or even better for energy efficiency. Sometimes there's a point of diminishing return. So they go through that, they look at stringencies analysis, they present their case, and sometimes things get reversed. And when it does, it's better for everyone to be in that process to not hinder some of the build process. So you'll see some of those changes that come up, and it's kind of oh wow, I thought we were always going to progress further, and now we're sliding backwards. And it's not really that we're sliding, it's they've come to the realization that some changes may not make a whole lot of sense. So we'll go through some of that. As for the 2024, here's what the American Council for Energy Efficient Economy, it's ACEEE, has to say about what's the driving factor for updating the stringencies of the energy code. Its residential and commercial buildings are responsible for approximately 40% of U.S. energy consumption. Energy codes are one of the strongest tools for reducing energy use and emissions for new buildings. Stronger energy codes are also essential for the equitable energy efficient economy because they set minimum standards that all buildings must meet, ensuring that no household or business is a new building is left with needlessly high energy bills. So that's kind of why we're all passionate about doing this. The IECC is no longer just thought of in ways to reduce energy consumption of a building. It's now looked at and looked upon as a key or one of the keys for meeting the goals for reducing greenhouse emissions and lowering the carbon footprint of a building. So when you have cities, municipalities, or even counties that have to look at presenting to the states their greenhouse gas emission plans, their the reducing of their carbon footprint, they rely on cities to give them the information on what is it we're going to do in our region, and then how you present that to the state. And so when that happens, using an energy code like this, updating a newer energy code helps reach those goals much quicker, and actually has a more reliable source of we're getting there by different means. But as long as you update an energy code, you're still helping that same goal to reach the same area. It's estimated again that the 2024 IECC, just like the 2021, will again provide another 9 to 12% increase in energy efficiency. Of course, that is dependent on what climate zone requirements you have and what climate zone you're in. More of a cooling predominant climate zone like Texas is highly based on the cooling side of a building, and then the further up north you go, the more it's relying more on heating. So reducing heating electricity consumption is better for northern climates, and same is for the southern climates. You're trying to reduce the cooling loads to be able to offset that for a reduction in energy consumption. So that's kind of what they're saying around the marketplace and the industry that we're in, and kind of where this is going and what we're trying to do. So now we'll get into the whole divvy of it. So it's scope and general requirements we'll go through first. Some of this is lengthy, some of it's wordy. I really didn't want to put a lot of words on a slide. I don't have a lot of examples of things. I just want to discuss what was presented, probably what their intent was on the presentation of it. We don't have the commentary book out yet that has layman's terms in it and pictures to provide better understanding of the intent. But reading through it and reading between the lines and being experienced in this for over 10 years, it's an easier way for me to look at it and say, oh, this is probably why they did this and probably why they meant that. They did update the scope of the IECC. It used to just be one sentence, and now it reads differently. So it says the code applies to the design and construction of detached 1 and 2 family dwellings and multiple single family dwellings, townhouses, and group R2 and R3 and R4 buildings that are 3 stories or less in height above grade plane. So what they did was they further defined it to include and have an inclusive of what all these buildings are that are included in the requirements of the residential section of the IECC. You know, we all know, we've talked about anything beyond that 3 stories falls into the commercial. So we'll go through that in our other webinars that we have about the commercial side of it. But this was their intent, was just to broaden the scope of what it's looking at, because a lot of people read things. They say that's not what I read. That's not the intent that I am understanding. So they try to clear that up with just administrative changes to the code. They also basically drastically modified the intent. Just residential provisions provide market-driven enforceable requirements for design and construction of residential buildings, providing minimal efficiency requirements for buildings that result in a maximum level of energy efficiency that is safe, technologically feasible, and the life cycle cost effective, considering economic feasibility, including potential cost and savings for consumers and building owners, and a return on investment. So as you can see, they went, in my opinion, they've reached out a lot further to hit all the high points that everyone's going to say or have an excuse of, that's not technologically feasible, that's not cost effective, the ROI is too far out. So they've started including that in the intent of what they're looking at. Yes, they take those things into consideration, but at some point you have to make the requirement. Manufacturers will catch up. There are time frames of cities for enforcement and just having technology reach that. Additionally, the code provides jurisdictions with the optional supplemental requirements, including requirements that lead to the achievement of zero energy buildings, which, as these new cycles come out, that will be more and more of a play in the energy code, is net zero and zero energy buildings. Presently and through guide paths that achieve zero energy buildings by 2030, that's still a lofty goal. That is still what they're trying to hit. And on additional timelines sought by governments and achievement of additional policy goals as identified by the Energy and Carbon Advisory Council, which now has a little bit of say-so in some of the energy requirements, and approved by the board of directors. The code may include, but not limited to, prescriptive and performance-based pathways. The code will aim to satisfy code requirements to facilitate the code's use and compliance rate. The code is updated on a 3-year cycle, with each subsequential addition providing increased energy savings over the prior addition. But as we said in prior webinars, now that we have this new ANSI standard process, they actually are going to be changing things during that 3-year cycle that will present itself on the digital I-codes that are listed on the ICCSafe.org's website, and you'll be able to look at those codes. So when you get a book and you get a hard copy, that may change, and something in it may change, and the newest and latest update will be online. The IECC residential provisions shall include an update to the Chapter 11 of the IRC. Before, way back a few cycles ago, it used to be you could use Chapter 11 of the IRC or you could use the IECC. That meant inspectors had to know the difference between the two of them and know the changes between the two of them. But that's no longer the case anymore. Chapter 11 is in the IRC, Chapter 11 is the IECC. And so anytime we get a change to the IECC, it will be updated on the IRC as well in Chapter 11. The code is intended to provide flexibility, permit the use of innovative approaches and techniques to achieve this intent. That's still in play. That's still what they want. They do not want to stop progression in innovative approaches. I think I saw an article last week about a new graphene style insulation. It's kind of like a continuous insulation board that's going to have a very high R value per inch. So things like that can be done. It may not be fully understood by inspectors, but you can't slow the progress of innovation. The code is not intended to abridge safety, health, and environmental requirements contained in other applicable codes or ordinances. This sometimes gets to be a hindrance of if you go talk to, or when I talk to a city and I explain to them some of the energy code stuff, some of them repeat back to me, if it's not health and safety, I'm not really concerned with it because I'll let the third parties take it. And that's fine, except the more times I go walk the grounds of a construction site, I come to a realization that you might be doing that as a city because you don't have the manpower. You're not IECC certified. You allow a third party to come in and do the inspections, but yet you need to know when it's wrong and when they're not actually doing those inspections, or they're passing things without meeting the intent of the energy code. And that still happens today. If I went and walked the job site today, I know exactly what builder I'm going to go look at because I know for a fact whoever's doing their energy inspections is not doing and following the energy code to the T, and the city is just letting the third parties slap a green tag on it. Always been something that I am not a fan of, and I like to try to help cities with the enforcement. I like to show pictures as much as I can to show this is when it's wrong, this is when you should call it out, this is when you need to have a meeting with the third party to say, hey, I've walked a few houses down the street, these have other builders using other third parties. Why are you not calling out the same thing? Consistency in my book is key to every bit of this. So getting that down, that's kind of what I try to do and hope to do in the webinars that I provide. Above code programs, this has always kind of been in the code book. They've further explained the what that actually looks like, what it means. Of course, we know from other webinars, Texas also adopted the House Bill, I believe it was 1736. Now that was the one that actually did the code, but it leaves me now. But they actually approved Energy Star and HERS as a compliance pathway through Texas instead of using the energy code. But it now says buildings approved in writing by such an energy efficiency program shall be considered to be in compliance with this code, where such buildings also meet the requirements identified in tables R405.2 and the proposed total building thermal envelope UA, which is the sum of U factor times the assembly area, shall not be less than or equal to the building thermal envelope UA using prescriptive in these tables multiplied by 1.08. So it used to be it would just say equal to or less than. Now they're saying, well, you can do that, but it needs to have a multiplier added to the prescriptive requirements of the table by 1.08. In other words, it can't just be equivalent. It's got to be a little bit higher than that. That's how they're squeezing more energy efficiency out of what's already there, is you can't really require them to do much more. So what you're doing is making that threshold a little tighter or a little higher or a little lower, depending on what you're looking at, to maximize energy efficiency. The area weighted maximum fenestration SHGC is permitted in all climate zones 0 through 3 to be 0.30. So that also is adding a requirement there. You can use an above code program, but you're still going to follow through the maximum fenestration for SHGC at 0.30 in climate zones 0 through 3, which includes everything all the way north of Texas. So there are slight changes that do happen, and they just try to better clarify what they're looking at. One addition to the information that's required on construction documents was this little one here. It was just R103.2.2. It's solar ready systems. The construction document shall provide details for dedicated roof area, structural design for roof dead and live load, and routing of conduit and pre-wiring for solar ready zones to electrical service panel or plumbing for solar ready zone to service water heating systems. So what you're doing is the builder is now going to have to put this on their construction document so that the building officials, the inspectors, the third parties know what to look for when they're actually inspecting solar ready systems and the construction of roofs and loads and where the conduits are running and the pre-wire for all of this stuff to know that it meets the requirement of the 2024 IECC. So that's a lot of the solar ready, EV ready, solar charging, battery banks, battery backups, renewables. All of that is really just digging more and more deeply into the code, and it's no longer just an appendice of the IECC. It's making it into the requirements of each of those chapters. Required inspections. This is one where I've talked about before that some cities are already taking advantage of this and moving it into their 2021 adoption. But as you can see, everything in red here was added to this. So what they did was they split the air barrier and insulation inspection in two, and now one of them is framing and air barrier rough-in inspection. Then there's an insulation and fenestration rough-in inspection. Then they also added an electrical rough-in inspection as well, because that deals with the renewables and the solar and the conduit and all the way back to the panel. It looks at that part of it. So air barrier inspections at rough-in shall be made before application of air impermeable insulation and shall verify compliance with the code as to fenestration properties, U factors, SHGC, proper installation. Air leakage controls is also required by the code, so that needs to be on the approved plans, and the specifications need to be listed. The exterior air barriers may be inspected after insulation is installed if everything is on the exterior as an air barrier and not part of a component that's designed to be multiple layers. So if you have one that's not calling in the part of the we call it a polyseal, a pre-installation inspection, if it's not being called in, as long as they're using cavity insulation, using T-ply or OSB or a zip board, or they're using continuous insulation, if that's the exterior air barrier, then it's okay to do it after insulation has been installed. It's usually easier for the third parties to see it before insulation's installed. However, if you have those builders that are now doing wall blow, they're also doing foam, they're doing things that cover all that up, it's harder to see imperfections in the air barrier. Insulation and fenestration rough inspection. So insulation inspections at insulation and fenestration rough shall be made before application of the interior finish, which is the sheetrock, shall be used to verify compliance to the code as to types of insulation, the corresponding R values, and their correct location and proper installation. Fenestration properties such as U factor, SHGC, and proper installation can also be verified at that time. Electrical rough inspections, those are basically there for electrical rough-in shall comply with what's required by the code and approved in the plans and specifications for their locations, distributions, the capacity of the electrical systems, where the solar ready zone is installed for electric generation. Inspections shall verify conduit and pre-wiring from solar ready zone at electrical panels. So I know from being a energy inspector in the field, I was never looked to getting an electrical certification. However, since renewables and solar and wind and all this is coming into the energy code, it's basically it's in your best interest to learn these things and to learn how to inspect and what this looks like. I don't have this in our presentation, but we did partner with IREC. It's IREC. If you look them up on Google, you'll find them. They do have online free trainings for building officials and third-party energy inspectors to learn how to inspect solar readiness. And so there's other entities out there that has free trainings that can help you to learn how to look at these and how to inspect them to make sure they're compliant. So that was the end of chapter 1. Chapter 2, there are very, very many numerous definitions that were added, including one, surprisingly, that when I read it, I had to go back several code cycles thinking, we've dealt with this for many, many years, and now it's showing up to be something new in the definition section. And sure enough, they included it in the chapters and in the section of requirements, but they never actually truly defined it. So now they're defining these things, and some of these will be very clear to you when you read through it. But we've got approved sources now, an independent person, firm, or corporation approved by the code official That's key, approved by the code official. And every time I go speak to cities, I always talk about a third party energy needs to be treated as such of any other contractor out there. They must register with the city. The city should be verifying that their certificates and their licenses have not expired and they've been renewing their certifications. They're on the up and up with the newest and latest code requirements that are out there. Otherwise, they're inspecting off older versions of the codes without fully understanding the new requirements of the energy codes. So, who is competent and experienced in the application of engineering principles to materials and methods or system analysis. So, automatic shutoff control, a device capable of automatically turning off loads without manual intervention. That's really getting to be a big part of the code is automation, with especially with controls, automating controls, taking out the manual need for someone to turn off and on a switch, because you can't really rely on that to help curb energy consumption. But it's a device capable of automatically turning off the loads without manual intervention. The automatic shutoff controls include devices such as, but not limited to, occupant sensors, vacancy sensors, door switches, programmable time switches such as time clocks, or countdown timers. So if somebody walks in, turns a timer on that counts down 20 minutes, that's the same kind of thing. If it's an occupant sensor that once someone leaves, it starts counting digitally down 20 minutes and then it turns off. Same kind of thing there. So door switches, once a door is open, it triggers a timer to start and then it shuts off. Automobile parking space. I know this sounds kind of, why would you need to identify that? But when people read things and they look at it and you're trying to cut costs in a project, if it's not fully identified and it's not fully defined, you can read it differently in the intent, and you can make an argument that sometimes is hard to maneuver and navigate through if they've got a full-blown argument to work with. But it's a space where a building or private or public parking lot, exclusive of driveways, ramps, columns, office and work areas, for the parking of an automobile. So if it's a driveway and someone's trying to ask you to do certain things to it that's included in a parking space, you can look at this definition and say, oh, this is a driveway. This is not intended for being a parking lot. It's not intended for cars to be parked on it. Ramps and columns such as that can actually fit into that as well. So it helps both sides of the coin. Construction documents, again, this is one of those where this has been in the code for multiple versions, but why they suddenly had to identify it was probably because they had people misreading the intent. But it's written, graphical, pictorial documents prepared as or assembled for describing the design, location, and physical characteristics of the elements of a project necessary for obtaining a building permit. They just fully defined it to say, this is what we mean when we say this is the information you need on construction documents, and this is the type of format that you need to have given to the cities for permit documentation. Demand response signal, it's a signal that indicates a price or a request to modify. I don't know if the price was the actual right word, that may have auto-corrected. To modify electricity consumption for a limited time period. So it's, again, demand responses, automated controls. This is just really big in that. And then they, of course, identified even further down from that, demand responsive control. The first was a signal. This is a control, which is capable of receiving and automatically responding to a demand response signal. So some of these that we talked about in prior requirements of the 2021, if you've got a demand responsive control, but it has a manual switch that someone can override it, it needs to now be capable of resetting itself to automatically responding to signals and actually turning things on and turning things off, even though someone manually turned it on and accidentally left it on. Then you got a distribution system efficiency. It's the DSE. It's a system efficiency factor that adjusts for the energy losses associated with delivery of energy from the equipment to the source of the load. So it's not just that you've got something plugged in or something wired. It needs to be able to adjust when you've got energy losses associated with delivering of energy from equipment and source loads. So we talked about in the 2021, or what we did prior in the 21, we looked at some forward thinking in the 24. It's grid integration, how things can adjust their efficiency factor by means of different sources of loads and where that's coming from to adjust that for the building. This is a big one. E is split up into like three different slides. You've got a definition of electrical vehicle, EVs. And again, it's just fully defined as an automotive type vehicle for on-road use, such as passenger automobiles, buses, trucks, vans, neighborhood electric vehicles, which I think if you read it probably includes golf carts, and electric motorcycles, primarily powered by an electric motor that draws current from the building's current electrical service. It's defined, or basically there's a definition further in the next slide that's an EVSE. It's a rechargeable storage battery, a fuel cell or photovoltaic array, or other source of electrical current. They're just trying to, now that you've got requirements for having EV stations, EV charging stations, need to start defining what it is that's plugged in that's considered an EV, and then they're going to start looking at how you actually monitor and curb efficiency, or give the efficiency of those. Electric vehicle capable space. Then you see the next one, it's ready space. So it defines what a capable space is. It's a designated automobile parking space that's provided with electrical infrastructure, such as but not limited to raceways, cables, electrical capacity, panel board, and other electrical distribution equipment space necessary for future installation of EVSEs. And so that is when you start looking at it, and maybe that building that's being built or that home that's being built isn't going to have a charging station, but if it's now required to have the future installation of one, now you need to set up a capable space of that actually happening. So that's why they're defining this now, is they're going to ask for that space to be there and to be capable of having future electrification for EV charging. And then you've got electrical vehicle ready space, which is an automobile parking space that is provided with branch circuit and either an outlet, a junction box, or a receptacle that will support the installation of an EVSE. So in other words, you've given it its space, you've given it its electrical components that's needed to design and designate a EVSE. And so what that is electrical vehicle supply equipment. So what they're doing is defining what all does that mean, what all is encompassing in that. It's the equipment for plug-in power transfer, including underground, ungrounded, grounded, and equipment grounding conductors, and the electrical vehicle connectors, the attached plugs, the personal protection systems, all other fittings, devices, power outlets, or apparatuses installed specifically for purposes of transferring energy between the premises wiring, the panel, and the electrical vehicle. So they're trying to encompass everything that when you talk about an EVSE, that's including all of the attached components. And then you also have the EVSE space, which is an automobile parking space that is provided with a dedicated EVSE connection. So not only do you just have a plug there, but it's also got the equipment set up to actually plug in a vehicle to get ready for that. And then on the E, now we're out of that part of it. We got emittance, which again has been part of the code, but just now defined. It's the ratio of radiant heat flux emitted by a specimen to that emitted by a black body in the same temperature and under the same conditions. I don't have a definition, and they didn't define the definition of what a black body is. If you Google that, I'm sure there will be one up there, but it's something that actually emits radiant heat, and so you're looking at a way for that and the ratio of what that is. So manufacturers, if they have a product or a paint or a film or something that's applied, you want to know what its emittance is. In other words, what's the ratio of radiant heat emitted by that piece under these different temperatures and under the same circumstances and conditions. So enclosed reflective airspace, this is a new one, an unvented cavity with low emittance surface bounded on all sides by building components. So it's defining more of you may have a reflective airspace, but if it's not unvented, it doesn't meet that definition of an enclosed reflective airspace. So if you're having a building that's requiring, or a component or layers of components requiring an enclosed reflective airspace because you're trying to take advantage of the R value of that, it has to be unvented. And then this one surprised me. We had the ERI section of the book for many, many code cycles. They just now added it to the definition. So how they define it is a numerical integer value that represents the relative energy performance of a rated home as compared with the energy performance of an ERI reference design, where an ERI value of 100 represents the energy performance of the design An ERR value of 0 represents a home with 0 net energy performance. So when you design a house, when you're doing an energy model, you're comparing it to the reference design, and that's a virtual house built to the same code level in a software. And what you're doing is comparing what's being built to that reference design. So what they're saying is that reference design being built to minimal code standards of the 2024 is equivalent to 100. Anything lower than that is better than that reference design. You still have to have the requirements that you need to meet, and they're no longer called mandatories, but you've got specific section requirements that have to be met, but you're still trying to get to 100 or less of the reference design. And sometimes they make it even, you have to be 85% of the reference design to actually comply. And then you've got exterior wall envelope, a system or assembly of exterior wall components, including exterior wall finishes and materials that provide protection of the building structural members, including framing and sheathing materials and conditioned interior space from the detrimental effects of the exterior envelope. So they're just defining, we have a building thermal envelope, but this is now defining what an exterior wall envelope is. They're kind of splitting those components a little bit. Then we have a new one that's called F factor, which is thermal transmittance. So we have U factor, we have R value. U factor is the heat transfer through a window, and then R is resistance to heat transfer. The F factor is now the thermal transmittance, but it's specific to the perimeter heat loss factor for slab on grade floors. So it's another factor that's in there that's actually trying to determine the heat loss factor of a slab. And so that you'll start seeing some of that listed in the energy reports and energy modeling reports that's coming to in your permit documentation. And then grade plane. Again, this is another one of those that surprised me because we've always had this verbiage in the code about grade plane. But now they reference a reference plane representing the average of the finished ground level adjoining the building at all exterior walls. Where the finished ground level sloped away from the exterior wall, the reference plane shall be established to its lowest points within the area between the building and the lot line, or where the lot line is more than 6 feet from the building between the structure and a 0.6 feet from the building. So again, if people misread that interpretation, they saw finished grade or they saw grade plane and they looked at it and said, well, that could be any portion of this. It varies between how it was sloped away. Sometimes you have different, if it's on a slope already with a lot, you've got more exposed foundation as you go down the slope than you do in the back of the sloping of the lot itself. So they've now defined what it means and where you're actually going to measure this from. If it has to be a specific distance away, then you've got, this is how you measure it. This is what you look at when you're determining that. So as we go through this, more definitions will be in part 2. We're going to go through a whole lot more on the next one. So now in the general requirements, not really a lot has changed. That includes the climate zone map. You know, in 2021, we got the ASHRAE map. That did change some of the climate zones. A lot of them had to be moved up. Tarrant County, Dallas County got into 2A. Texas saw its first 1A. So did Florida. And a lot of things were changed. There's also a climate zero now in climate zones. And so the map stays the same. It doesn't move. So thankfully, there was no changes through any of the cities in Texas or Oklahoma climate zones. The building thermal envelope insulation. So this first part in blue did not change. What they did was they further had added details to what's listed on the certificate. Now they say for reflective insulation, the number of reflective sheets, the number and thickness of the enclosed reflective airspace, and the R value for the installed assembly shall be listed on the certificate. That's the same thing as it's what's in commercial. You probably don't really see something like this in residential, although it is in the residential part of the book. It's going to say the same thing in commercial. So it's just basically going to say if you have what's called the reflective airspace, which we saw the definition of what an enclosed reflective airspace means. If you have it, then on your certificate, you need to actually have it installed where have the thickness of it, the number of sheets that are used, the R value associated with that assembly has to be listed on that certificate. What they're trying to do is better the inspection process for the installer to give you what it is that they installed per the manufacturer's specifications of R value so that when you inspect it, you know that it's meeting and it's complying with the code, because you can look at this certificate. It moves liability to the installer to say that they did it correctly and that they used this material by this manufacturer that gave this R value. And now you can look at that and you can determine that, yes, it's compliant. Instead of you having to do the research in the field, trying to find out what this material is, who makes this material, what R value does this material have, is it installed properly, you leave that liability up to the installer. Same thing with this, the installation mark, it's not really changed. It basically just says, you need to have insulation that's readily available with a mark. However, if it doesn't have that, you need a certificate posted immediately after installation, like for foam, fiberglass wall blow, cellulose, all that stuff. You need to have a certificate immediately after installation that shows that. But in red, they added, for roof insulation installed above the deck, the R value shall be labeled as specified by material standards in tables 1508.2 of the IBC or the table R906.2 of the IRC. So now they're having you reference another I code to determine it's actually compliance with that. So that's, as we say, if I read it slowly though, it's the roof insulation installed above the deck. This does not include foam that's sprayed to the deck that's under decking, not above decking. So if you have outer insulation or outsolation installed with a continuous foam board, then you need to look at another table in a different code standard or another I code to determine compliance. So I know some of it gets very confusing with what's going to happen, what's actually looking at and what we're talking about, but you need to reference it in a different section. Now radiant barriers finally made it into the code. So where installed, radiant barriers shall comply with the requirements of an ASTM standard C1313/ or a C1313M. So before it was, we all know radiant barriers power. We know it's low emissivity. It absorbs heat. It doesn't re-radiate heat. It does not have an R value. It's not really ever been listed in the IECC because it doesn't have a R value property. How do you determine its effectiveness without an R value or a U value? But we all know what it can do is lowering attic temperatures, and it's very powerful in doing that. So now it's made it into the code, but it now says it must comply. If you have radiant barrier decking installed in residential, it's probably already complying with that. I wouldn't worry about it, but if someone has sprayed it, if they've used a roll-on fabric stapled underneath the rafters, then you need to make sure that they're following an ASTM standard. Again, you'll also see more compliance with that when you're looking at commercial to actually, did they actually do the correct thing here on how they did it. So now we'll get into the residential energy efficiency section of that. Again, I did not make it all the way through chapter 4. There is just a whole lot of stuff to unpack here. The pathways with that, we have prescriptive compliance path. They've renamed it again. It's now simulated building performance option, not total building performance. It's simulated performance option or simulated building performance option. You still have the ERI, and then you now have that tropical climate regional option, which actually came in the 2021. That compliance pathway is still there. This is one thing that I'm kind of happy to see, but when you see it in part 2 of what they replaced it with, kind of gives you that wah-wah moment of, well, they took this out because it was difficult. Most cities were actually not even they were amending these things out. They were not requiring it in 2021. However, in 2024, the addition that they added back into it to offset this, somehow it makes it a little bit difficult. But what we see here is the option 1, 2, 3, 4, and 5 doing the additional efficiency, energy efficiency measures. This has been completely removed from the code. It's just no longer there. Like I said, there you'll see in the part 2 in 2 weeks what they replaced it with, which does add a lot more complexity to compliance, in my opinion. The certificate hasn't really changed. So a house is completed for the final inspection. These certificates should be posted on the electrical panel, on a furnace located in a utility room, or any other place approved by the building official inside the building. If it's located on the electrical panel, it must not cover or obstruct the circuit directory label. So little change between the 15 and 18, and the 21 added some different things to it. They added the expansion of tell me what energy code addition you're on and what compliance pathway you're following. Also, what relative information do you have for photovoltaics that's being installed? Also, if you're following the ERI, then please give me the ERI score. A lot of time that's just a preliminary because the person doing the final doesn't really know the final ERI until you run a confirmed rating on the home. Then you know the final ERI, but normally it doesn't deviate by too much. But now they've included the additional energy efficiency measures selected for compliance in R408, which used to be those additional option 5s that we just saw. It's now the one I was talking about that's a little bit more complex. They took it from the commercial provisions of the book and they moved it into residential. So it's now R408, which before R408 was the explanation of how you do the additional energy efficiency measures. So it's still called the same thing. It's just changed, and you'll see more of that in part 2. And then also where a solar ready zone is provided, the certificate shall indicate location and dimensions. Again, just helping the inspector when you're on site determine where these solar ready zones are located and also what the dimensions are and what you need to be looking for when you inspect it. So third parties, I know a lot of city officials will, or building officials, code officials will actually get more involved in that because now you're looking at the load carrying of the roof and where the solar panels are going to go and the electrical infrastructure of that. But you're also going to have the help from the third parties. They're accounting what the dimensions are, what the locations are, if there's solar panels there. Did they install the right KW of solar panels? Did they install the right number of solar panels? All of those things are being accumulated and collected by the third party that can help a building official determine compliance. So when you see these stickers, hopefully determine that the third party has also verified these things, that you can now not have to have that as your responsibility to look for. The tables, a lot changed with the tables. The first table that's now in line is the U factor table. So a lot has changed with that. They moved the components to the left instead of across the top, because across the left is the actual component and across the top is the climate zone, where it used to be the other way around. But as you can see, these values, not many people look at the U table, the U factor table for compliance, because it's easier to read the R value when it comes to ceiling insulation and wall insulation. So we'll move on to the next one. But there are some footnotes that happen with the U table. Footnote D and footnote footnote F, which is roofs and insulation entirely above roof deck. We saw that earlier about the F factor. The roof, it's a roof insulation for it, not the F factor, my bad. This is the next one. Footnote G is F factors for heated slabs correspond to the configuration described by footnote D. And in footnote D, the R value table talks about the insulation requirements for heated slabs that must have R5 under the slab, in addition to the required slab edge insulation in climate zone 3 and above. But it also gives guidance to say if you're using heated slabs with R5 underneath it and you're doing slab edge insulation, you're not permitted to have to go and extend below the slab. So if you look at just a regular slab needing slab edge insulation, you have to bury it per its requirement in the guideline tables up to 2 feet to 4 feet, depending on your climate zone. But if you have heated slabs, you don't have to extend below the slab because you also have R5 that's placed underneath the slab. So those footnotes are important to know. I'm sure that'll be, if you take the test for 2024, those footnotes will also be good to know that. The R value table, a lot changed here. This is what I talked about earlier by saying, wow, now they're going backwards. Climate zone 0 and 1 didn't change for ceiling insulation, but they reverted it back to 38 in climate zones 2 and 3 from 49. Then they reverted back to 49 from the 60 in 4 through 8. So a lot of people made the argument of there's a point of diminishing return, and usually that's around 42. Once you hit 42, adding more insulation doesn't increase your energy efficiency. It doesn't add more resistance to heat transfer. It just is what it is. You just add more material for not much more of an impact. So they've lowered that. They've changed the U factor for the skylights. Fenestration had changed a little bit with that. Floor R value, they've now added the continuous insulation option So instead of using 13, you can use 7.5 or 7 plus 5, or you can use a complete 10 continuous insulation. So they added that instead of saying, well, I'm doing 7 plus 5, and I should get equal equivalents to the 13. But if you add those two together, they don't equal 13. So that's when they're looking at it and going, well, we're going to deem that these are just as powerful. And then that's about all on the changes for the R table. There are footnotes with that. Footnote I, roof insulation. It's the same thing with the U, and then J, though they kind of further define what that means when they started adding that to the flooring insulation, where it says 30 or 19 plus 7.5 or 21 means 30 cavity insulation alone, or 19 with 7.5 continuous, or 20 continuous alone. We know that from previous code books. But they changed that and added another footnote to actually understand that a little differently. Component performance alternatives. So you're looking at the UA total trade-offs. I just went ahead and copied and pasted and put this in here because it was just convoluted to try to reword that into a slide. But they took out total UA. They made it a component performance alternative. Basically, they're talking about the proposed and the thermal conduct. The thermal conduct, I can't even say that word. And then required the building thermal envelope. So a lot of it, they've got an equation here at the bottom that needs to be followed. And what they've done is they define what each of those components are in the equation. So thankfully for us, as we look through all of that, it's determined by a software. When you look at rim rate and you look at res checks, those actually will be able to do these components with that, as long as those are updated res checks and updated rim rate and ecotrope. So there are others that are out there, total building reports that you can use. It shows compliance. As long as those are updated to understand the new requirements for the 2024, which sometimes those lag a little bit behind because they're waiting for that to actually be final drafted and then adopted in anywhere for actually the changes to take place. This, we've known it for a long time. It's been in our talks and our webinars talking about knee wall, how you insulate it, how you fully enclose it, how do you encapsulate it, how do you air seal it. But now they've added its own section. It's R402.2.3, attic knee wall. And it says attic knee wall assemblies that separate conditioned space from unconditioned spaces shall meet the same insulation requirements as above grade walls. So they're now determining and telling you the requirement of, it can't just be you're gonna blow attic insulation against it, and you're just gonna have it part of the attic space, and you're gonna just blow a lot of insulation over it, or you're gonna put a different level of insulation in it, such as R11 or something like that. We don't normally see something like that, but they're just further defining that to say attic knee walls are now going to be considered the same as above grade walls that extend into the attic. Such knee walls shall have an air barrier between conditioned and unconditioned space. If they leave it like this, the intent, some people are going to read and see that and say, well, you have that already because it's called sheetrock. Well, in the code and in the energy efficiency world and in building science, you consider the cavity as part of the conditioned space. So having an air barrier between conditioned and unconditioned space is the side facing the attic. It's not the interior facing conditioned space. It's on the exterior of that wall facing an unconditioned space. That's the air barrier that's required. That's now telling you that all knee walls need to have it fully enclosed, a back air barrier facing unconditioned space, an interior air barrier facing conditioned space, and then sealed on both sides and top and bottom to fully encapsulate and enclose the knee walls that are here. I'm glad that they went through that. I'm glad they actually further defined it and made its own section. I'm sure there'll be additions to that in the future, but that gives credence to third-party energies that keep calling these out and saying, look, I need this knee wall to be fully insulated, and I need it air sealed, and I need to have an air barrier on the backside facing an unconditioned space. A lot of them just said, well, if I read the book, it just says it's between conditioned and unconditioned, which is the sheetrock. I've heard that multiple times in the field. This one they finally did bring up as well. We see truss framing being brought back in full force with roofing, just building those trusses off-site, trucking them out there, laying them on the front of the yard, and then throwing those things up to more quickly speed up the process for, instead of stick framing, you're actually doing truss framing. I have a picture on the next slide that will help explain what this is. It's hard to tell in a two-dimensional picture, but it says where vertical roof truss framing members are used to separate conditioned from unconditioned space, they shall meet the same insulation requirements as the above grade wall. So if you look on how these things are made, pay close attention on which way the 2x4 is turned. You know, they do it this way for the ease of putting those not the nail guards, the actual joints, the joint fasteners here to hold those together. Everything is on their wide face, so it makes a thinner profile. But if you think about this, and if you make a two-story out of this, and part of that is a stairwell leading up to the second floor, well, if you're using these trusses as the wall, you can't get R13, you can't get R15, you can't get R19, you can't get anything more than 1.5 inches worth of insulation in that cavity space. So it has to be furred out and further built to actually hold insulation. This picture, I know this is not a truss system. This is more of a close-up of what it would look like. This is a one I've showed before in webinars. It's a wall above a fireplace. But as you see, the studs are turned on their widest face. So when I pulled the insulation back, it was only 1.5 inches deep. There was T-ply and an air barrier behind it, which basically only gives you half the R value of an R15 bat. It was 7.5 roughly, depending on how well they tore it. So to me, that's not compliant. And I did see that multiple times when the truss systems came out for roofing. They were just shooting the stairwells up through those roof rafters or through the truss systems, and then they were just enclosing those truss systems with T-ply on the back, and then trying to put an R13 bat in the front of it. It's just not going to work. It's not compliant. You can't do it that way. You've got to reframe it. Yes, it's difficult. Yes, I understand it takes time on site to redo it. You're already cutting time off by actually having the truss systems installed. Now the framer's got to take more time to actually reframe that to actually hold the insulation requirement. So again, I know it's some one of those things where it's going to be more difficult on site, but it just needs to comply. Now that they've written it into the code and it better specifies what it is that's determined for the intent of this, you must have the same equivalent insulation requirements as the above grade wall that you're building in. So if it's 13, you got to have 13. It's got to be the same thing. However, when it comes to the climate zones where you're having to do 13 plus continuous, I'm assuming you're still going to have to do continuous in the attic side of that. I don't truly know how that would be determined. Again, it's leaving the intent open for explanation for a building official to look at and go, yeah, I'm not going to require the continuous board outside in the attic space, but I will require it on the exterior wall. I don't know the true answer to that. It depends on how it's actually being designed for that part of it. Attic access hatches and doors. So they've reworded a lot of this. This is shows that there was addition in the 24. I read it, I reread it, I read it again, looked at the 21. There was no change. But if you go to the draft that's current, they actually showed this in blue writing as if it was something new, especially for those 2.1, 2.2, and 2.3. It shows that those were new, even though it's the exact same thing in the 21. So not a lot of changes with that. Still requires that all those areas must be met, 2.1, 2.2, 2.3, and the 2.4, which is the perimeter and the hatch shall be weather stripped. The net area of the frame opening must be less than or equal to 13.5. Not less than 75% of the panel area shall have insulation R value of 13. And the average U factor of the hatch shall be less than or equal to an R10 or a U.10 for the average insulation for that part of it. So it's just determining what you need to do for that part. Steel frame, ceiling, walls, and floors. The option to use a table was kind of removed from that. So the U factor requirements now must meet an R402.2, 0.1.2. The calculation of the U factor for the steel frame ceilings and walls in the envelope assembly shall be determined in accordance to an AISA SIS 250. I don't know that standard. I didn't read through that standard, but you're looking at that to say that's how you're going to determine that. They used to have the table to say this is the equivalence, and you look at it and say, well, if I'm using an R13 wall, it's 2x4, then the equivalence to that is X, which would most likely be like a 13 plus 5 or a 13 plus 7. you have to have continuous insulation to cut the thermal bridging of the steel studs. But now you need to look at and reference a different standard to actually determine compliance. With this, the floor, a few word changes to the requirements of the floor. I put it in red here, but it's just talking about that. I took a picture of this part of it being improper location for that insulation. It should be in contact with the floor above. That may be a roof deck because I see nails poking through. This was just one that I could find where it wasn't facing that OSB board. So if that truly is a roof deck, that doesn't have to apply. It's correct the way it is. If it's conditioned floor above and what we're looking at below us is a garage, then it needs to be placed above that OSB board. But as you can see in number 3, it basically says the R values of cavity and continuous insulation components, or the R value of continuous insulation only, shall equal the required insulation component R values for floors. So what they're still doing is just adding more interpretation of, if you're using continuous insulation, then it's going to be compliant as long as it's hitting the same R value. And then cavity insulation shall extend to the bottom to the top of all perimeter floor framing members, and the framing members shall be air sealed. So they just added the words cavity insulation for that part. It used to be just say insulation, so they added a few more words to that for better explanation. And then slab on grade floors. This is in this section they added a lot more words again for better clarification. What they did was they added the word in contact with the ground. And then they changed from 12 inches up to 24 and added the words above or the already above grade. So they basically added the slab grade floors in contact with the ground with a prior floor surface with a floor surface within 24 inches of above or below grade shall be insulated in accordance to that table. So they just added that for better clarification. When you look at slab on grade, again, grade is now being defined, but when some people look at that, they're determining, well, if I'm using a concrete slab, but it's over a unconditioned garage area, is that on grade? Is that a slab? Do we consider that a slab? So now they're trying to better define and better explain what that means when they're looking at for slab on grade floors, so that you can determine what is required at that area when you're determining compliance for the energy code. Same thing for crawl space installations. They added a few more additional words. I went ahead and put on here what was marked out. They basically shortened it and just said crawl space wall insulation shall comply with the following. Before it was where it's installed be permanently fastened. Now they just broke it into 2 separate requirements, and they're just saying crawl space wall insulation must comply with the following. So again, this is administrative changes that happen to the code books to say, let's better clarify what we're intending for this to happen and what we're intending that we needed to do, and that's how we're going to define it and explain it. Room. It used to be where it just said sunroom insulation. Now they've added the and heated garages to this. So this is meant for the walls separating sunrooms and heated garages from the conditioned space for the specific insulation requirements of the code. And basically says, there is exemptions if they're thermally isolated. There's different ways of looking at it. If the sunroom is thermally isolated from the building, then you handle it differently than if it's attached to the building and that one wall is separating between conditioned spaces. If they're separated, it says if they are, then the minimum ceiling insulation shall be 19 in climate zones 0 through 4, and then 24 for climate zones 5 through 8. Minimum wall insulation shall be 13 in all climate zones. So what they're doing is saying, well, that greenhouse and or that heated garage, even though it's really not part of the conditioned space in the livable dwelling, it is being conditioned in some fashion. So it needs to have minimal insulation values to it. So then now if it's completely isolated from the conditioned space, then you're going to not have to meet that same requirement of a dwelling being conditioned. And then it says the walls thermally isolating these conditioned spaces shall comply with the building thermal envelope requirement. So the walls between those, even if they're isolated separately from that wall needs to be looked at as an exterior wall and comply with the building thermal envelope requirements of the code. Radiant barriers, we talked about that earlier. It's now finally made it into the code, but not without specific guidelines. And so it does ask for that ASTM this one actually says we're installed to reduce thermal radiation. Radiant barriers shall be installed according to ASTM C1743. I did look that up. It's a standard practice for installation of and use of radiant barrier systems, also known as RBS, in residential building construction. The scope of the standard is to increase the thermal effectiveness and reduce the risks associated with improper installation practices, such that increase fire hazards and promote deterioration of the structure. So improper installations can contribute to fires by heat buildup in recessed lighting fixtures, the deterioration or failure of electrical wiring components, deterioration of wood structures, and paint failure due to results of moisture accumulation. When I sold radiant barrier, we didn't even think about that. That was never part of our understanding. We always were in it to sell it. So when you sold it, yes, it has power. Yes, it lowers the radiant heat in an attic. It lowers the temperature of an attic. It increases energy, the actual comfort of the home, and reduces energy consumption for heating and cooling. So that was our main takeaway, our main benefits that we sold off of. However, now looking at it from a standpoint of an ASTM standard, they're looking at it from a practical standpoint of fire hazards, mold and moisture, deterioration of wiring components due to the fact that you've got moisture buildup because you have a very hot surface against a cold surface. Because even when it's sunny outside, but it's cold outside, that radiant barrier, that radiant heat is still making it somewhat into the attic. It can heat up a radiant barrier surface, and any cold surface against it is subject to condensation. So it needs to have proper installation done. There's now a standard that needs to be followed for that. I'm glad to see that it made it into the code. There are different types out there we talked about earlier. There's radiant barrier decking, there's spray on or rolled on paint, there's rolls that can be stapled underneath the underside of the roof joist and the roof truss members. So when that happens, it now needs to follow a standard to make sure that it's properly being done, because you need to look at it from a health and safety issue. So a lot of changes to the air barrier and air sealing and installation table. It's a mouthful, but it's now listed as R402.5.1.1. This is where most of the third parties get their checklists from, and it's the one that has the air barrier criteria per component and a insulation installation criteria per component. So more clarification and additions were added to this. Ceiling and attics are better clarified for air sealing and insulation, and then windows, skylights, and doors have additional or added insulation requirements as well. So for ceiling and attic, they added the words air sealed, not just air barrier, shall be installed. And then at the bottom, you see it says access openings, pull down stairs, at knee wall doors, unconditioned spaces shall be air sealed with gasket materials to allow for repeated entry over time. This is where I have a point of saying I'm glad to see they added that, because a lot of times when I did inspections and we had a scuttle hole, the builder said, look, I'm not going to put weather stripping on there because it's going to be sealed shut and not for homeowner use. We know all too well that the homeowner is going to cut that and use it for storage because it's just convenient. So this is specifying it needs to be with a gasket material that allows for repeated entry over time. They can't just say, well, I'm just going to seal that shut. And then on the insulation side of it, it says access hatches and doors shall be installed and insulated in accordance to a specific section. Eave baffles shall be installed according to a specific section. And then windows, skylights, and doors now have a installation criteria saying framing cavities around windows, skylights, and doors shall be completely filled with insulation or insulated per window manufacturer instructions. So before it would just say it needed to have the space between it needed to be sealed. So you just had that spray foam around it. But depending on how the window is framed or the door is framed or a skylight is framed, it may leave a bigger section or opening in the wall. It now is saying that it needs to be insulated per that manufacturer specifications or completely insulated per the building thermal envelope requirements of this book. And then the only thing on this page here, they did add basement and crawl to the crawl space and slab foundations. The reason crawl looks like it's new is because they had to go from an uppercase to a lowercase, so that was a change. Really what they did was they add the word basement to this requirement. So that helped specify some of that in the basement section of that. A lot of changes here. I'm glad to see these changes. Showers, tubs, fireplaces have been clarified as adjacent to building thermal envelope and not just on the exterior wall. So that now includes knee walls, second floor attic walls, not just, well, it's not on the exterior wall because that's what it says. It's adjacent to whatever is considered the building thermal envelope. And then for air sealing section, it clarifies that an interior air barrier must be installed that separates the insulation from the shower, tub, and fireplace. Again, another one of those things where I still find today people using and being allowed to use netting in front of insulation just to hold it in place. This better clarifies that you must have an air barrier between the shower tub and fireplace and the insulation inside the wall. It cannot be a net or netting that allows for air movement. Electrical communication and other equipment boxes, housing, and enclosures have been changed to encompass all equipment and enclosures and removes the on exterior wall designation. So where this comes into play, a lot of times where I saw them installed were on the garage wall. And if it was on the garage wall, a lot of people said, well, that's not an exterior wall, so I don't have to follow that requirement. But now it's removing that and saying in the building's thermal envelope, which again helps with the clarification as to what's required. So it's basically saying anything penetrating the air barrier shall be caulked, taped, gasketed, or otherwise sealed to the air barrier element being penetrated. So if the air barrier is the garage wall, and even if it's the sheetrock on the back side, it needs to be sealed. It encompasses all of that. So, and also, it says all concealed openings into those boxes, housings, and enclosures shall be sealed. So if you have a communication box, like a internet provider gives the boxes that have all the holes in the back of it, those need to be sealed. But if you seal them, you're voiding the warranty of the equipment because you're not allowing air movement through the box. I.e., there's a reason why you should not be putting it on an exterior wall and or thermal envelope. You must put it or should put it on an interior wall that now you don't have to follow those requirements. The continuity of the air barrier shall be maintained around boxes, housings, and enclosures that penetrate the air barrier. So it's basically saying everything through that. That's the sheetrock. So it's basically saying if your sheetrock is part of your air barrier system in your wall, you must also maintain that around those enclosures that penetrate through the air barrier. Relatively or alternatively, air sealed boxes shall be installed in accordance to R402.5.6. And then on the insulation side of it, it says now it's requiring boxes, housing, and enclosures shall be buried in or surrounded by insulation. Again, we can read that intent and go, well, if I cut around the box, it is surrounded by insulation. However, when it says surrounded by, it means on all sides except what's facing the conditioned space. So they're now asking for insulation to be behind those boxes. Most builders now just squirt a bunch of polysil behind it, and if that's complying and you think that's enough R value per inch to meet the outside wall, I guess that's still going to be allowed. But if you're looking at water heater boxes on the exterior wall that's fully filling a 3.5 inch cavity, it still needs to have insulation behind it. Well, if it's only 3.5 inches and the box itself for the water heater is 3.5 inches, how do you get additional insulation? You've got to construct the wall in a way that you can get that insulation in it. That's 2x6s. That's furring out the wall. That's whatever you need to do to not have a quote unquote, I'm using air quotes, a quote unquote hole in the wall that's allowing for thermal transmitting of heat through that hole that's in the wall. A lot of times that's in the main bedroom's closet, which they say, well, that's just in a closet. But however, if that closet keeps getting hot, I mean, people may turn the thermostats down just to keep that, or they'll have a complaint because that room's not getting conditioned like it should. So lastly, we have HVAC register boots now have the insulation requirements to be buried in and surrounded by insulation. The majority of HVAC contractors already do that. There are boots out there now that are made with styrofoam that have R8 on them. And so that's already insulated, but even the neck of those collars need to be insulated. They should not have metal boxes being exposed to attics that are not insulated. The older boxes used to have insulation on the inside of them, but those were not meeting the requirement for duct insulation. So they were like probably an R3 duct board that was on the inside of them. Those cause a lot of condensation, a lot of mold issues. So really you need to have the insulation on the outside, not the inside of the boots. But I still see them used from time to time. So that's a lot of changes that happen with that part of it. the last part of that, common walls finally were addressed in this table. This is something I argued with a lot with these townhomes, is that it's not an exterior wall. It doesn't have to be air sealed. It doesn't have to have insulation. It doesn't have to X, Y, and Z. They leave a lot of open chases to that. In the 2024, they finally addressed it. They added a complete new component with 2 requirements: air sealing materials recognized in a listed fire resistance rated common wall or double wall design and installed in accordance with the listing, or air sealing materials recognized in approved design shall be used. That to me tells me that this is also saying if you have fire caulking that's approved by the fire marshal that can be used to stop air on common walls between dwellings, it shall be used to stop air movement. A lot of times they would say we can't use wood or we can't use polyseal because it needs to be fire rated. The fire marshal won't allow it because it needs to have a fire break. But if you have material that's fire resistant rated, it can be and should be used to stop air movements between those common walls. There's always that channel that holds the wall off of the actual fire blocking, and it allows for air movement between floors and air movement between dwelling units. It now is addressed to where they can actually seal it. Then it says common walls or double walls shall be considered an exterior wall for purposes of air barrier and air sealing applications of this table. So now it's telling you, just because it's a common wall and it's between 2 conditioned spaces, they need to be looked at as exterior walls for all components. That's air sealing of electrical boxes, that's adding insulation if it's needed, that's air sealing the wall itself, that's closing off the gap at the top and the bottom with fire resistant methods of air sealing. So thankfully this got addressed. It was a long time coming. The insulation requirement is insulation materials recognized in the listed common wall or double wall design and installed in accordance to the listing, or insulation materials recognized in the approved design shall be used. So if it's R11 and that's going to be acceptable because it's between conditioned spaces, you're using it for deadening, sound deadening, then that should be acceptable. And that's going to be fine. You don't really have to meet that same requirement of an exterior wall insulation. However, you need to meet the intent of exterior wall for air sealing. So I'm glad to see that actually happened. I'm glad to see it's finally in the book to help with shouldering the burden of a third party having to fight the builder to get this done when there really wasn't a true call out in the code book. Some footnotes to that to actually take note of was inspection of log walls shall be in accordance to IECC 400. That's not really new. But then B, insulation full enclosure is required in unconditioned vented attic spaces at rim joists. So that was a good one to be able to see. So what it's trying to tell you is a lot of builders would, when I actually talk to them about, hey, we need an air barrier here, we need an air barrier under the stairs, we need an air barrier on the back of knee walls, their funny comment was always, well, if that's true, then why don't we have an air barrier on top of the attic ceiling insulation? Well, that's why you have R38, R49, and R60 is because you're slowing the resistance to heat transfer, and no one expects you to put an air barrier on top of it. Now the footnote specifically says for attic spaces that are vented and unconditioned, you don't have to have a full enclosure. Same for rim joists. You don't have to put an air barrier in front of the insulation on a rim joist. However, now you do have to permanently have it installed where it doesn't move. It's not just friction fit. It's permanently installed, but you don't have to put an air barrier because it's trapped between a conditioned floor. So you don't have to put the air barrier. So I know a lot of that was rather lengthy, rather wordy. That's the end of part 1. And so I will bring up part 2 in 2 weeks. I'm still actively building this. If you have questions, by all means, email me. Let me know. We'll talk about it. Be sure and join us for our next webinars. Next week, we've got proper insulation, and why it matters for the energy model. It's really kind of another way of me talking about grading of insulation, looking at field peak pictures about what is and isn't good, how it's graded in the field, and talk about why it matters in the energy model. Maybe even looking at 2 different energy models of the same building with different grading to see how much that affects the model. And just look at, this is why third parties exist, to be able to grade insulation, not just is it installed. If it's there, yeah, that's fine, it's insulated. but the proper installation is more effective on the heat load of the home than you think. So we're going to look at some of those and talk about it. And then part 2 of the residential 2024 IECC, that's November 7th at 10:30. Both of those are 1.5 hours. You'll get credit for 1.5 hours of time. And so my contact information is here. Again, share this with anybody. If they have questions, by all means, point in my direction. I'll be happy to help. We still have ongoing training throughout the state of Texas and Oklahoma. And so happy to hear from any of you guys in the future. So thanks again for joining us. And as we did in prior webinars, I will end the recording and I will stay online for a few minutes to answer any questions that you might have. So thanks again for being here and look forward to seeing you guys next week. Appreciate it. All right, I am still available and